It'll forward it. It's going to receive it on FA9, but it's going to forward it FA5. Okay, what about question 2? It's going to add the source. Let's see, the source is 0F. It already knows where the source is, okay? It's not a broadcast. Isn't it 3? Okay. All right. Wow. Okay. Let's try another one. The destination is 0D. It knows the destination. Okay, the source is not in the table, right?
Yeah, so just a point source.
Okay. So where will the switch forward the frame? Okay, so it's going. The switch will receive the frame. Okay. Well, the answer to 1 is FA7. It's going to send it to FA7, right? Okay. Okay. Yeah, it's going to add the source MAC address to the MAC table because we don't see the source in the MAC table. And what else, Brian? Okay. All right. All right, here's another one.
So we automatically know too when we switch after the source connected.
Okay, so Brian's saying we know that number 2 is going to be this, right? Because the source 0A is nowhere in the MAC table, so it'll learn it. So the frame is a broadcast frame. Is it a broadcast frame? Is it a broadcast frame? Is the destination F? Okay. Frame is the unicast. Okay. Why will it be flooded to all ports? It doesn't know what the destination is? Okay, so what do we do here? Why did you select 3? Active port. Why not 2? Inactive. Okay. Yeah, 1 is the source. All right. All right. Yeah. Last one. Where will the switch forward the frame? The source is known. 0E. Destination's unknown. Okay, so it'll be a unicast. Why is it a unicast flood again? Oh, okay. It's not FF, so it's not a broadcast. But it does. But the switch does not know the destination. Okay. One, 3, 5, 7, and 9. Is that correct? The source is 9, right? Yeah.
Where your source is also a lead.
But I already mentioned it. Notice unread, which is also the only other thing.
So do we leave it checked?
I think
Uncheck it?
it's probably wrong.
All right, let's see what's up. Correct. Why is it correct?
Because everything that's coming into FA9 is 9.
Right. The switches assume that everything that comes into FA9 is known by everything that's attached to FA9. Okay. And plus switches
That's
don't.
really messed up.
Well, look at it. Let's take a look at the diagram here. The source. Well,
That's only because you got Mac code to it. You have to know the device connected to the whole. It's not Mac code that it knows.
okay, that's an excellent point. Excellent point. Yeah, excellent point. All right. Let's. Okay. Yeah, do this switch operation packet tracer at your leisure. It probably will encompass some of the concepts we covered in the packet tracer that I kind of enhanced, or the packet tracer activity that I enhanced. Okay, this is the ARP process. We went over ARP as well in the previous packet tracer, but please go through this activity at your leisure. Also this one. All right, proxy ARP is a concept that may be confusing to some. Let's look at this logical and physical topology. Okay, on this side of the router, network that's associated with interface 0, it's 172.16, and it should be 10.200/24. That's what it should be, because we look at the other side of the router, we see that those IP addresses are /24 as well. So basically the 172.16 has been subnetted. But however, PCA has not been properly configured. We see that its address is 172.16.10.100, but it's a /16. So that's incorrect, okay? That creates a problem. What problem is created? Okay. Okay, let's look at it this way. Imagine we're at PCA, and we ping IP address 172.16.20.100. PCA is under the impression that PCC is on the same network, right? So really there's no need to send an ARP request for the default gateway MAC address, right? There's no need to go through the default gateway. If we're thinking as though we are PCA, because PCA is on the assumption that, you know, 172.16.20.100 falls within the 172.16. The /16 basically tells PCA that anything that starts with 172.16, whatever, it doesn't matter what the last two octet values are, that particular device is on the same network that you are on, okay? That's what PCA is thinking, right? Okay, you with me so far, right? Okay, so what will happen in this instance? PCA needs to know PCC's MAC address, right? So PCA is going to generate what type of broadcast? ARP, right? Okay. Where's that ARP going? It's going to leave PCA, go along this line. It'll get to the router. The router will notice it. Also, PCB will get it, right? In this instance, the router is aware that PCC is on the other link. It's on a different subnet. The router is aware because it's attached to both of those subnets, right? So what the router will do in this instance is it will respond to the ARP with its MAC address, okay? So what will happen is PCA will send the packet to the router because it's going to send it to the router's MAC address, and the router will forward it to the correct location. Okay. It still worked in this instance, but don't rely on proxy ARP. Okay. Now, what if PCC was 3 routers away? In that instance, proxy ARP wouldn't really work. It worked in this instance because the router is aware that it's directly connected. Yeah. So. Right. So hence you understand where proxy comes in, right? The router is answering on behalf of PCC. Okay. All right. Any questions about anything we've talked about thus far? Please note this page. That's 9.7.3.1. Also go over the ARP issues, 9.7.4.1. Let's see what this is about. Okay, this asks you to use the Windows ARP utility. I've done that on a previous recording. Now let's take a look at it here. Let's see. Go to Command Prompt, type ARP, and then there's a switch we need to use. Go with ARP. So looks like the -A. Okay. I have multiple interfaces on this PC, and each interface has its own ARP cache. Okay.